Today we are discussing electric motor. What is electric motor? Electric motor is an electrical machine that converts electrical energy into mechanical energy. Electric motor works on the principle of Ampere law and Faraday's law. An electric motor consists of two components, stator and rotator. Stator. A stator is a static component which consists of magnetic materials and electrical conductor to generate magnetic fields of a desired shape. Rotator. A rotator is a rotating part which is made from magnetic and electrical conductor to generate shaped magnetic field which interact with the fields of the field generated by the stator. How rotator works. The rotator comprises the moving component of the motor having a rotating shaft to connect to the machine being driven and some means of maintaining an electric contact between the rotator and the motor housing, typically carbon brushes pushed against slip rings. In operation, the electric current supplied to the motor is used to generate magnetic fields in both the rotator and the stator. These fields push against each other with the result that the rotator experiences a torque and consequently rotates so that a motor should work. Rotator working. The induction of current flow through an induction electric motor's rotator bars occur when current is applied to the stator. This applied current through the stator windings start the rotation of the stator's magnetic field at line frequency. The rotator bars of the stationary rotator are then subjected to the maximum relative motion of the stator's magnetic field to the bars. At this point, maximum current is generated along the bars. As the stator north pole rotates past a rotor, rotor bar, current is inducted along the rotor bar. At the same instant, the stator south pole rotates past a bar 180 degree apart and induces current along that bar in the opposite direction. At the same instant, the stator south pole rotates past above 180 degree apart and induces current along that bar in the opposite direction. The circular flow of the current along the rotor bars through the shorting rings and around the laminations causes the rotor to become an electromagnet. The electromagnetic rotor will begin to accelerate to synchronous speed or the speed at which the stator magnetic field is rotating. If the motor's load is increased, the motor speed will decrease. Also decrease in the load will increase the speed of motor. An induction motor will never reach synchronous speed due to friction and winch losses. The difference between synchronous speed and induction rotor speed is called slip frequency. As you can watch in figure how rotor coils works.
In this figure you can see stator is the stationary part or outside part of the motor, and this stator have no role in running the motor. Rotor coil or rotor is the rotating part of the motor which has to produce electricity. Commutator is the part of motor which has the rotor to move. Brushes you can see in this figure holds the commutator to move smoothly, whereas shaft is the inside part of the motor which allows the motor to move. Or to calculate the RPM of the motor, we use the following formula: 120 F over P. Basically, NS in this figure, as you can see, is the RPM which we calculate, or number of turns which we can calculate through this formula. F is the frequency of electricity which is measured in hertz. The frequency is generally 50 hertz or 60 hertz. P is the number of poles which the motor have.
Now we are discussing types of electric motor. Electric motor consists of two types, that is alternating current and direct current, AC or DC motors. Alternating current motors consist of synchronous and induction, and induction consists of single phase and three phase, whereas direct current motors separately excited and self-excited. Self-excited consists of three layers, that is series, compound and shunt. Most commonly used motors in daily life are as follows. Number 1, AC brushless motor, DC brushed motors. Number 3, DC brushless motors. Number 4, stepper motors. Number 5, stereo motors. Number 6, linear motors. Number 7, direct drive motors. Now we are discussing operation of DC motors. The operation of a DC motor is dependent on the interaction of the poles of the stator with a part of the rotor or armature. The stator contains an even number of poles of alternating magnetic polarity, each pole consisting of an electromagnetic formed from a pole winding wrapped around a pole core. When a DC current flows through the winding, a magnetic field is formed. The armature also contains a winding in which the current flows in the direction illustrated. This armature current interacts with the magnetic field in accordance with Ampere's law, producing a torque which turns the armature. If the armature windings were to rotate round the next pole having opposite polarity, the torque would operate in the opposite direction, thus stopping in the armature. In order to prevent this, the rotor contains a commutator which changes the direction of the armature current for each pole pieces that the armature rotates past, thus ensuring that the windings passes, for example, a pole of north polarity which will all have current flowing in the same direction, while the winding passing south pole will have oppositely flowing current to produce a torque in the same direction as that proceed by the north pole. The commutator generator consists of a split contact ring against which the brush is applying the DC current side. The rotation of the armature windings through the stator field generates a voltage across the armature which is known as the counter EMF. Since it opposes the applied voltage, this is the consequence of a Faraday's law. The magnitude of the current EMF is dependent on the magnetic field strength and the speed of the rotation of the armature. When the DC current when the DC motor is initially turned on, there is no counter EMF and the armature starter starts to rotate. The counter EMF increased with the rotation. The effective voltage across the armature windings is the applied voltage minus the counter EMF, as shown in figure.
Figure shown is the inside of the DC motor. In this figure, magnetic field is moving from north to south pole
Types
of the
of DC
magnet. As you
motors.
can see in this figure,
Following are the types of DC motor: permanent
commutator
magnetic DC
is
motor,
moving the
separately
rotor
excited
from
DC motor,
south to north
self-excited
pole.
DC motor, shunt wound DC
Direction of
motors,
current which is
series wound
produced
DC
by
motor,
this motor
compound
can be
wound DC motor,
calculated by using
short shunt
Fleming's rule.
DC motor, long shunt DC motors, different differential compound DC motor. These are the types of DC motors. Most commonly used DC motors are as follow: permanent magnetic DC motors, series DC motors, shunt DC motors, compound DC motors. Now we are discussing permanent magnetic DC motors. The permanent magnet motor uses a permanent magnet to create field flux. This type of DC motors provide great starting torque and has good speed regulations, but torque is limited, so they are typically found on low horsepower applications. Now we are discuss series DC motors. In a series DC motor, the field is wound with a few turns of a large wire carrying the full armature current. Typically, series DC motors create a large amount of starting torque but cannot regulate speed and can even be damaged by running with no load. These limitations mean that they are not a good option for a variable speed drive application. Now we're discussing shunt DC motor. In shunt DC motors, the field is connected in parallel with the armature windings. These motors offer a great speed regulation due to the fact that the shunt field can be excited separately from the armature winding, which also offers simplified reversing controls. Now we are discussing compound DC motors. Compound DC motors, like shunt DC motors, have a separately excited shunt field. Compound DC motors have good starting torque but may experience control problems in variable speed drive applications. Now we are discussing types of AC motors, alternating current motors. Classification based on principle of operations. Synchronized motors, asynchronous motors, induction motors, squirrel cage, slip ring. Commutator motors, series repulsion, compensated repulsion, start induction, shunt repulsion induction. Classification based on type of current, single phase and three phase. Now we are discussing synchronous motors and its uses. These motors have the rotor which is connected to the load rotating at the same speed as the speed of rotation of the stator current. In other words, we can say these motors do not have slip with respect to the stator current. They are sometimes used not to drive the load but instead act as synchronous condensers to improve the power of factor of the local grid to which it connected to. These kinds of motors are used even in high precision positioning devices like modern robots. They can also act as stepper motors. What is asynchronous motors and its uses? The most common form of motor which is used in everyday life, from pumping water up the overhead tank to power plant boiler feeds pumps, these kinds of motors rule. These motors are very flexible to use and matches the load demand almost of for everything. The most widely used induction motors are very important for many industries due to their load bearing capacity and flexibility. These motors, unlike synchronized motors, slip when compared to the stator current field. These are generally used for various type of pump, compressor, and act as a prime mover for many machineries. Now we are discussing single and three phase motor and their uses. The AC motors can find their uses in two forms based on the power supply. The single phase motors are generally found their use in low power requirements appliances like ceiling fans, mixers, grinders, portable power tools. The three phase motors are generally you found for high power requirements like power drives for compressor, hydraulic pumps, air conditioning, compressor, irrigation pumps, and many more. Thank you for watching. Stay tuned.